Good morning. Let me know who you are, Rain. Help me out helping you. If you got a question. Figures. Hi, Hayden. If the rest of you are watching, remember you can also ask questions through Remind or email if you can't access the chat. You can use a personal Google account to join the chat, but for some reason, Coventry's blocked you guys from accessing chat and from subscribing to YouTube channels off of your Coventry email. A little annoying in our current situation, but we can work around it. We'll start in a little bit going through the daily post. Wait for a few more people to show up if they want. The DNA question is posted. You can be working on that. Your form is under classwork under references, sheet 22. I would use Roll Tide to help answer those questions for the DNA prompt today. I would leave it open too because we want to finish it today. Hopefully turn it in before you're done. If not, you have until midnight. If you're on a personal account, you gotta let me know who you are so I can figure out how to help you. I know Rain's Rainy. I know HWR is Hayden. Rotten, don't know who you are. Levine, alright. Hi, Hike. Hi, Logan. What's up, Astrid? Hi, Azura. You're quiet today, Azura. Oh no, that was Maddie yesterday, playing my YouTube video, not realizing it. Interesting. So you're answering your DNA right now? I'll be posting the notes as a comment to the post in Classroom later, toward the end of the stream. Well, after the stream's done, I'll be posting as a comment. You can check your answer and fix that. All right? Just as a hint, use roll tide. What phases of the moon seem to cause extreme tides? What phases of the moon seem to relate or cause minimum tides? How would I do that? Well, again, I should have had a a lunar calendar for February 2020. That should be in roll tide down below. I also have tidal data in number 1 in roll tide for Watch Hill. All right, and what I'm looking for is every day has a high tide and a low tide. It's got almost 4 tides. Some days kind of get caught off at midnight, like February 6th. Most days have 4 tides. All right, too high, too low, alternating. Takes 6 hours to go from one tide to the next. It takes 12 hours to go from the same tide to the same tide. So crest to crest, high tide to high tide takes 12 hours. Why? Because it takes 12 hours for the Earth to rotate, facing the Earth and then rotating away, the moon, facing the moon, then rotating away from the moon. All right, and we're going to diagram that today as the second part of the agenda. All right, the third part of the agenda is just finishing roll tide, doing the evaluate. All right, and again, if you don't finish it by the end, we're done streaming, then you have until midnight. All right. So you are looking for these tides at minimum and then at maximum. They're most extreme and then they're most minimal. All right. These tides from the 1st to the 5th, really not even the 5th, but to the 4th, they're very minimal. They go up a little bit and then they come back down a little bit. All right. So high tide, low tide isn't as extreme as would be from the 8th going until about like the 15th, almost a whole week. All right. Probably really peaking in its extremity right here, 10th to the 12th. And then it starts getting minimal again, and then it starts getting a little more extreme again. So why? If you look at the lunar phases, oops, which ones relate? All right. So I said back in our tidal data, like the 1st to the 4th was kind of minimal. Well, what phases were the 1st to the 4th? And then I said, I keep going to that tab, said the 9th to the 12th was the most extreme. Well, what phases were the 9th to the 12th? So maybe even like a day before that, the 8th. So looking at those phases, we had the quarter and we had the full moon. So quarter and full moon. Quarter seemed to be minimal tides. The full moon seemed to be those maximum, really extreme tides, really high tide, really low tide. All right. So how is the moon affecting those tides? Maybe. All right. We'll get into this when we review roll tide tomorrow and move on to eclipses. All right. So again, this is the DNA question. It's 2 parts. Phases that relate to minimal tides, phases that relate to those maximum, those extreme tides right here. All right. From the 9th to the 12th. But then again, starts peaking around the 23rd, the 24th. So what phases are around the 23rd and 24th? All right. So to kind of further help you, we are going to look at full moon and new moon, 1st quarter, 3rd quarter. Which ones relate to extreme tides? Which ones relate to minimal tides? Because we're going to give those names. All right. Rainy. Olivia Krupka wants to know what's the diagram. Well, Olivia is just going to wait for a couple minutes, let people finish up their DNA who are working on it right now, and I am going to, where is it? There we go. Do it with you. You're going to do it in your DNA sheet, probably at the bottom. Do an insert drawing or do it on paper and take a picture. This is our electronic notebook. All right, so number 2 is together. It's not really an assignment, just taking notes. And then 3 is finishing roll tide. Logan, would a giant wave affect the cycle of high tide and low tide being every 12 hours? Yeah, would a giant wave? No, the wave would crash on the beach like a tsunami, and it would raise the sea level for a little bit, but it would not be considered a different tide. You're not going to change the cycle because the moon is going to be dictating the cycle, not a giant wave. All right, you can almost kind of think of high tide as a wave in Earth's water. It's the water getting pulled towards the moon. We'll talk about how that causes high tide in just a second when we diagram it. In order to go far inland, yes, Hayden, you're right. Tsunami needs to pull back out to the sea in order to go into land. If you ever see the ocean go out for a mile, like sea level drop out a mile, then you're in trouble. Most common cause for tsunami, earthquake underwater. So the sea floor is geologically active, and hopefully we get to talk about that after we finish the solar system. and our galaxy and our universe. Talking about space. We'll go back to the Earth, talk about geology, and tsunamis and earthquakes are part of talking about tectonic plates. If we're all good with the DNA and we're waiting for that diagram, let me know in chat. You can send me an email or a remind. Brady, if you're watching, Brady asks, so I made 2 diagrams for the DNA question. Does it have to be color or pencil? It can be whatever you want, Brady, whatever helps you remember. Color might help you remember because I'm going to use color here when we diagram tides. Obviously, blue for the water, black will just be the moon and the earth. It's not going to be like the seasons diagram or the lunar diagram. It's going to be based off the lunar diagram, but I'm only going to show the moon in one spot. It's going to be about the earth moving, rotating. So Rainey's all set. Hi, Kim. Good. I gotta see who else is in the chat, because some of you are quiet. It only shows 5. Huh. Alright. Again, if you guys are stuck on the DNA, you can always ask me a question or go back once this video is done. Alright? So, diagramming tides on the Earth. Let me make it bigger and get my face out of the way. Okay? What we want to focus on, hi Eric, is drawing the Earth. And bear with me, this might not be perfect. This is our Earth. Going to give it a tilt in the axis. And we're going to put our moon over here. For this whole diagram, this little sliver is our S. It is our sun. Yes, Miss Dortreys is guidance counselor. All right. So with this, we're going to say this is the new moon because it's the moon closest to the sun. All right. You are standing right here, right underneath that moon. All right. This is, if the moon is right overhead, you're right under it, and it's the new moon, because the new moon is out during the day from 6 a.m. to 6 p.m., then it's going to be halfway between that day. So that means it's going to be noon. So time is going to be important here because it's going to tell us, when the tides are going to happen. So we have our new moon, we have our Earth tilted 23.5 degrees. It's 12 noon. You're underneath the new moon. All right. What tide would we have? Well, if you're closest to the moon can pull on the surface of the Earth due to gravity, which is an attractive force. Matter wants to attract other matter. Then the moon can really only pull on the surface water. Can't really pull on the Earth, of the Earth. All right. So the water gets pulled to where you are. because it wants to go to the moon, moon's gravitational pull. It doesn't fly off to space because the Earth's right there. It has stronger gravity because the Earth's closest to the water. All right. Well, if you pull water from one place, what happens to the water level somewhere else? You can't create or destroy matter. It has to be conserved. So if you take matter from one location, you gotta lower it on another location. So there's less water on the places on either side of what we would call a high tide. And so we call this low tide. Now, what about the opposite side of the Earth? Well, the moon can't reach with its gravitational attraction all the way to the back side. All right, and you also got to think of the water on the Earth as kind of like an elastic band, a rubber band, right? If you got one, you can go find one. You can pull on either side of it. You're gonna feel a tug from that low tide. And what happens is because the moon can't reach and it's pulling closest to it, some of that water actually snaps back and builds up. And that is high tide. And so hopefully you can kind of see just from this simple diagram, we're going to draw two more versions underneath. All right. This simple diagram shows you why do the tides alternate? Because the tides alternate at any given point on the Earth. High tide, low tide, high tide, low tide. All right. Actually, you know what? I kind of did this misleading. That axis shouldn't be there because it's giving you the point of view of a side point of view, and I'm doing this top down. So what I should have done is this. There's the axis. And it's a little bit off center. There. That's the axis. I can try and write it in real tiny right there. Okay, so now this is a top-down view. Before I was kind of misleading. It looked like side view of the axis, but I was looking top-down anyway. All right. Well, let's say we give it 6 hours. So we're going to do a 6-hour rotation. Kind of move that over. All right, and I'm going to draw the moon and the Earth again. You're now changing your location. Still new moon. Instead of 12 p.m., 6 hours past 12 p.m. is 6 p.m. Okay, this is again the Earth. You have gone 1/4 turn. Labeling the axis. Rainey wants to know, is the diagram part of the grade for the DNA? Is it part of the grade for the DNA? No, but if you don't do this and you don't understand it, good luck to you on the weekly quiz. So this is just like regular school, right? We do notes, we do diagrams. The weekly quiz is a weekly assessment of what we've done over the week. So everything has value. All right? Not a dumb question, but we're doing it for a reason, right? So, because we have done a quarter turn, has the moon really moved? No, it hasn't. It's going to move a tiny bit in its revolution around the Earth. It's not going to move much in 6 hours around the Earth. All right? So, the water from the Earth is still getting pulled to the same spot. Make that a little darker. And that means there's a lack of water over here, and then a bunch of water on the backside. And so what you can kind of see is the location of the tides don't change, but because the Earth rotates, your location on the Earth is going to have a different tide over 6 hours, and then another tide over 12 hours, and then another tide over 18, and then the last tide over 24. Okay? So you are at low tide. It's been 6 hours. Why? Because the Earth rotated. The water is moving, but it gets pulled like a rubber band towards the moon. The rubber band can go around in a circle. It can spin and rotate too, but that rubber band gets pulled to the moon each time. So it's like a rubber band moving around your finger. Okay? So again, I'm gonna hopefully I have the room down below. I'm just gonna continue and just do one more rotation, one more quarter turn, just to show you every 6 hours and every 12 hours. I'm not gonna go the complete day. All right? So there, we are doing another quarter turn. So Earth is rotating 6 hours. Again, we're rotating counterclockwise, right? And I'm going to just draw the same picture. So you can almost even do it on your own. Because now you're just going to be on the opposite side of the Earth that you started. So here's Earth. Axis is tilted away. So Northern Hemisphere, we're currently in winter. New moon. 6 hours gone by. We're now at 12 midnight. We'll add Earth's water. Water snaps back because the moon can't reach all the way around. And we'll add you. So your physical place hasn't changed, but you have rotated on the Earth. The tides don't change because the moon has stayed relatively stationary. All right? The tides will shift over a course of a month because the moon is moving just a little bit in its orbit every time you have a new tide. But for our sake, we're just trying to simplify it and just say moon's staying roughly stationary. All right? Add in our labels. This being high tide, this being high tide, low tide, low tide. Okay? So that's the basic part of the diagram. And then you could just keep drawing it. You could do another 6-hour rotation. You would be at the next low tide position. And then you would rotate again, and you'd be at the next high tide position. Okay? Every 6 hours, you change an individual tide, high tide or low tide. Every 12 hours, you go from the same tide to the same tide, high tide to high tide, low tide to low tide. Okay? again, just to kind of emphasize, what actually is a tide. High tide and increase in sea level due to the, there we go, moon's gravitational pull. Okay. So then what's low tide? A decrease in sea level. Due to the moon pulling water to another location. Okay. So in this diagram, I'm sorry for the messy writing, we've looked at why the tides alternate, why the same tide repeats after it alternates, why we have 4 in a day, what high tide is, and what low tide is. All right? And these definitions emphasize that you need you in line with the Earth and the Moon, or you at a right angle from the Moon and the Earth. So we'll put a little or there. Put it right in between. That now looks like the word ear. I'll just leave an E in there. You get the idea, hopefully. All right. Any questions that are applicable to tides instead of sharks and thunderstorms, Logan? If there's a giant thunderstorm, will that change the effect of high tide and low tide being every 12 hours? No, because thunderstorms don't control the tides. The moon does. So the location of the tides stay roughly in the same spot. The Earth rotates. So I don't want to say we move around them. We move from the location to location. We move from tide to tide. The tides stay roughly stationary. We move from one tide to another tide because we're on the Earth and the Earth rotates. But just because we're on the Atlantic Ocean, let's just say, like right here, that be the Atlantic Ocean during high tide, the Atlantic Ocean is still moving with us. So the Atlantic Ocean will have high tide, the Atlantic Ocean will have low tide. Okay? So don't think like the same body of water stays with the tide, right? The tide is just water being pulled like a rubber band moving around your finger. Right? You keep it on your finger, then you rotate it around. I wish I had one. I'd show it to you. Maybe tomorrow I'll find one. All right. But yes, the tides themselves stay in the spot. You rotate on the earth from tide to tide. Had someone email me saying that they did their DNA questions and they finished and handed in roll tide. Just keep in mind that this diagram is also going to be important because it's going to help you through this weekly quiz coming up on Friday. All right, it's going to help you finish roll tide too. All right. So either you're drawing this on paper, you're taking a picture, you're going to insert this diagram at the bottom portion of your online sheet. This is your electronic notebook. I'll make a box for it next time. Okay, but down here, maybe move your guidelines out of the way. That'll be like your electronic notes, your electronic notebook. Okay. But again, you are either going to take a picture, you're going to insert it in of your version of the diagram, okay? Or you're going to go to insert, drawing, new, and you are making this drawing with me. How do you get individual lines? Go to the line tool, go to scribble, and now you can draw in those high tides. Okay? If you can make a circle with, you can make a circle with the shapes. But a better way to make a circle, if you didn't already know, shapes, circle, hold shift while you click and drag, and it'll make a perfect circle. Okay? I can save and close it, but that's horrible. Goodbye. All right, so either take a picture, insert it in, or make a diagram for Google Draw, our electronic notebook. All right. Last part of today, you were to do the extend section, kind of, you did everything with a line. Oh boy. See how it turns out. Tides appear to occur cyclically. 6 hours transpire between the changing of tides, and 12 hours transpire between the same tides. We diagrammed that. Okay? If the moon is relatively stationary in its orbit around the Earth for a day, then the Earth will alternate, facing the moon and away from the moon at a 90-degree angle, then opposite the moon, and then away from the moon at a 90-degree angle. We diagrammed that. All right? Those are just words and descriptions of what we already draw. Then back to facing the moon in a new position for a new day. All right? Each of these quarter turns of the Earth will take 6 hours and appear to correlate with the positioning of the moon relative to location on the Earth. Further research is necessary using Google. So you were to find the lunar calendar, paste it in, include the link, and then 11, just simply what correlations or relationships emerge when the tidal data from Watch Hill compared to the lunar calendar. All right. So what we're going to talk about tomorrow is there are special versions of high tide and low tide. All right. They are called spring tide and they're called neap tide. So tomorrow is just kind of like a review and moving on into the next topic of modeling eclipses. We're going to go back to this diagram, but we're going to include what does the sun do? Because the sun has an effect here. Because the sun is so large, even though it's so far away, because it's so much mass, its gravity has an effect. Bye, Eric. If you're all set, you can finish roll tide. All right, turn that in when you're done. So what correlations or relations emerge? So again, you want to look at full moon, new moon, and then first quarter and third quarter. So your DNA answer is going to help you right here for number 11. All right. The evaluate section, this is what you are doing now. The evaluate section, number 12, how does the moon affect daily tides? Well, guys, this is how the moon affects daily tides. Its gravity is going to do what to the water? Okay. Where does high tide going to be on the earth? Where's low tide going to be? Why do we have low tide next to high tide? Because the water's got to come from somewhere. You can't just create matter. You can't just create, you can't just create a higher tide. Okay. 13, how do the lunar phases, positions of the moon and revolution around the earth, that's what a lunar phase would be, affect the monthly tidal cycles. So again, going back to full moon, new moon, first quarter, third quarter, some tides are more extreme, some tides are a little more minimal. All right. Why? Because the moon is in alignment with the new moon and full moon, with the earth and you, and it's at a right angle during first and third quarter. Okay? So, can an ocean lose their tide cycle? If the moon explodes, yeah. If you lose the moon, you will not have tides that we see every 6 hours, 12 hours. You still will have tides, but done by the sun. All right, the sun does play a role in the tides, as we're going to talk about tomorrow before we move on to eclipses. All right, so you would have a tide during the day, you would have high tide, and then at midnight you would have high tide, and then in between morning and evening you would have a low tide because you'd be facing the sun or facing away from the sun, or you would also be at a right angle with the sun. Okay. Thunderstorms do not have an effect on the tides. They do not have gravity. What you guys are describing right there depends on how the moon would come apart. If there are large enough chunks, you'd have some crash into the earth, you'd have some go off into space. Maybe you have a few asteroid-shaped moons. If you are a moon that got slowly shredded due to the planet's gravity, then you would make a ring system like you'd see around Saturn. Neptune will have one of its moons do that, and even possible for Mars. One of their moons will get too close to the planet, and due to their revolution around the planet, will start to get shredded due to the gravitational pull, but get shredded over time, and therefore outline their orbit or make a ring system. So Saturn's rings are not solid objects. Saturn's rings are ice balls, rocks, ice water in orbit in a thin plane around the planet. Some of them are as big as a car, some of them are as tiny as a snowball. Talk more about that when you guys start exploring the solar system. That's after your unit test. Keep in mind, we do have a unit test by Google form beginning of April. and my wife got me a rubber band. So if I had one finger as the moon and the other finger as the Earth going around it, they each pull the rubber band to them, which makes high tide. But in between, it gets strained. That's low tide. So the high tide and low tide change position based on rotation. All right. And she's been crying, Logan. Any other questions or concerns that aren't about moons exploding? Because I'm probably going to finish up doing an answer for the DNA question. Can you repeat number 11? I mean, you can read number 11. You want to repeat what I said for number 11? What correlations or relationships emerge when the tidal data from Watch Hill is compared to the lunar calendar? This is essentially what I'm asking with the DNA question. What phases of the moon seem to cause extreme tides? What phases of the moon seem to cause minimum tides? Take that answer, reuse that answer in number 11. So what phases? Hi, Jacob. A little late to the party. So what phases are going to correspond? New moon, full moon? Is it going to cause extreme tides or minimal tides? Okay. First quarter, third quarter. Is it going to cause extreme tides or minimal tides? How would I know? I have a lunar calendar, and I have up number 1, or I should, a screenshot to compare. What phases cause those extreme tides? What phases cause those minimal tides? Well, you're a good example, Jacob, because if you are late, because this is YouTube, the stream gets archived as a YouTube video. So that goes for anybody. If you can't in the future make a stream, all right, or you come in late, just wait for the stream to finish. You can watch it, rewind it, go back to it if you have questions, even if you were during the stream. All right. Biggest tide in Rhode Island is probably going to be if there was alignment of the sun, the moon, you, and then yes, maybe a thunderstorm, or probably more likely a hurricane. The biggest tide probably was during Hurricane Sandy, because hurricanes push a lot of water up onto land. It's called storm surge. It's probably the most dangerous parts of the storm. I believe Hurricane Sandy, I'd have to look it up again, but I believe Hurricane Sandy made landfall in the northeastern United States the same time there was a full moon, and it was in line with the sun, causing what we call a spring tide, which means a really, really high tide. So that was probably the biggest tide that I can probably pick off the top of my head. When Hurricane Sandy made landfall in 2012, that full moon in October. Okay. So, using your tidal data, what phases of the moon seem to cause extreme tides? What phases of the moon seem to cause minimal tides? Going back here. The extreme tides. Really large high tide or really small low tide. They seem to match up with new moon and full moon. The minimal tides. So smaller high tide and a larger than normal low tide. These minimal tides are going to correlate with first quarter and third quarter. Okay, what's my evidence for that? Back to my chart. We'll zoom in a little bit. These tides are real minimal from the first to like the third. It starts creeping up from the fourth to the fifth. So first, second, and third. Okay. First, second, third. All first quarter. So those minimal tides just matched up with first quarter. Well, where else do we have minimal tides? It kind of starts winding down again towards the end of the month. All right. End of February. We're starting to go back to another quarter. All right. But not quite. So is there a better look? Well, last quarter, or another way of saying third quarter. That was 15th and the 14th, really. They start getting a little more minimal. All right. There may have been something with the sun to kind of mitigate as low as it was there, or maybe a storm, kind of like how you were saying, Logan. It just affects the tides, doesn't change the tides. All right. That might have been possible. All right. So small anomaly right there. But whereas the really extreme tide right there from the 9 to 11th, go back 9 to the 11th, it's pretty much a full moon. Okay, so extreme tides are going to happen around new moon, full moon. Minimal tides are going to happen around first quarter, third quarter. Okay, so then the new moon. New moon was around 22nd, 23rd, 24th. 22nd, 23rd, 24th. Probably the most extreme you're going to have in these last 2 weeks of February. Okay, so it matches up. All right, the why is because during new moon and full moon, the sun is in alignment with the earth and the moon for the high tides. Okay? For the minimal tides, the moon is at a right angle of the sun and the earth. Right? So, kind of just like, I'm not going to diagram the tides again, but just to kind of show you. Sun, earth. Kaylee, that is supposed to be for February. It's my mistake. We've also been a little delayed, so that's why I carried on into March. This shouldn't have gone on into March. Well, this late into March. When the sun, earth, and moon are in perfect alignment, you're going to get these extreme tides. This is called a spring tide. Okay? The sun is helping the moon to pull more water to itself, takes more water away from the sides that we diagrammed earlier. The sun is again in line with the moon. Whenever they're in alignment, because the high tides are on opposite sides of the planet, you're going to be in line with the sun, the earth, and the moon. You're going to make a very large high tide, and then opposite, you're going to make a very small low tide. That's called a spring tide. Okay? So spring. Think of like a spring welling up. You have more water available. All right? So what's this situation down here? Well, the sun's not going anywhere. And remember, this is not the scale, obviously. The moon now here. Actually, you know what? Is at a right angle. Make the little dots a little bigger. Right angle. Okay? When it's at a right angle, we call this a neap tide. So not only do we have spring tide and neap tide, not only do we have high tide and low tide, we have high tide and low tide, and then we have special versions of high tide and low tide that only happen really twice a month. Spring tide and neap tide. Okay? So Logan had a good question, is when the largest tide was. Again, I said probably during Hurricane Sandy when it made landfall in the northeastern United States. That was around 2012 in October. All right. It happened during a full moon. So with storm surge and a full moon, with the extra gravity from the sun, you're going to have a really huge high tide. And that's why a lot of damage happened along the coast. All right. Neap tide, you would mitigate some of that high tide because the moon's at a right angle. And the moon is the primary cause of the tide. Keep that in mind. Okay, because the moon's closer. Gravity is stronger over closer distances. But it's also affected by mass. The sun has such huge mass that it does have a little bit of effect on the tides on the Earth. All right? So this was your DNA answer for this morning. All right? At the end of the stream. Kind of like almost a little review. All right? So just to kind of sum up, because even if some people have already left because they're pretty much set. If you're still here, kind of just to sum up what we've done and what you're going to be doing. All right. Answer the DNA below. I just did it. If you were stuck, all right, you can check yourself. I'm going to be posting that as an answer to the daily post for others to check and review too. Use that as notes for your quiz on Friday. Okay. Then diagram tides. We did that earlier. All right. That should be with you in your DNA sheet. Again, I'll probably post it with your DNA at some point as reference for the notes. All right. Complete the evaluate section of Roll Tide. Finish those last couple of questions, 12 and 13, and then turn this document in. All right. I'm only showing period A right now, but it's the same for each classroom. Due before midnight. Roll Tide. 14 people in period A have turned it in. Make sure the rest of you turn it into. All right. You shouldn't have much more to do. This wasn't a very long document, and I've kind of broken it up over these first couple days that we've been doing our distance learning to kind of get you just ready and familiar with how the process is going to work. The process of how this is going to work, being away from each other, out of the classroom, probably more important learning how to do that than working on a very, very long document. We'll have time for that. Modeling eclipses, and then a little bit of research on the planets in our solar system. All right? Any final questions? No, you can always send them. Through Remind or email. I'll be checking throughout the day. All right. Finish Roll Tide. I'll see you again tomorrow.